Hello everyone, welcome to Engineering Dojo. So today we'll be studying about central concepts of automata theory. Central concepts of automata theory. So this subject is also referred to as theory of computation. So these two are the same subjects. So the first concept they'll be seeing here is the concept of alphabet. So what actually is an alphabet? Any finite non-empty set of symbols is referred to as an alphabet. So what actually is a symbol? A symbol is nothing but a character, like we have alphabets in English A, B, C, D, or the characters we use to represent the numbers 0, 1, 2, or in any language like in Greek language. So these are nothing but the symbols. So the notation that we used for alphabet is sigma. So some example alphabets we'll be seeing here. So suppose we have a set 0, 1. So this is a non-empty set and also it is finite. So yes, we can say that it is an alphabet set, or we can have another alphabet set like A, B. So these are all the alphabet sets. The next concept that we have is the concept of a string. So what actually is a string? A string is a sequence of symbols chosen from some alphabet. So a string is simply a sequence of symbols. Suppose, as I've written here, we have this alphabet set 0, 1. So from this alphabet set, what are the possible strings that I can form? Like I can have simply a string 0 or a 1 or 0, 0 or 0, 1. These are the different strings and it goes on. So the number of possible strings from this alphabet set is, as we can see, is infinite. That is generally the case. So this is the concept of this of a string, nothing but a sequence of symbols. And we have another related concept here, which is the length of the string. So here we see that 0, 1. So how many symbols are there in this string? 1. So suppose we have a string is generally represented by W. So suppose we have a string 0, 0, say this is string W1. So mod W1 will be representing the length of the string. So here it is 2, because how many symbols are there? 2. So suppose W2 is simply 0. So length of W2 will be 1. And here we have a special notation which we say epsilon. So this epsilon refers to the empty string, means a string which does not have any symbol. So we always have the length of epsilon is equal to 0. This refers to the empty string. Now next we will see the power of alphabet. Suppose we have any set of symbols, any sigma. So for that sigma we can write different powers of sigma. Like suppose we have sigma is equal to, let's say, 0, 1. So sigma to the power 1 is nothing but sigma, which is 0, 1. So these are all the set of all the strings of length 1 that are formed from sigma. Similarly, sigma 2 is nothing but set of all the strings of length 2 that are possible or that can be made from sigma. So here we have 0, 0, 0, 1, 1, 0, 1, 1. Simply we take all the all the combinations which have two symbols from this alphabet, and similarly it goes on. We can have sigma 3, sigma to the power 3, or sigma to the power 4, and it just goes on. So these are the powers of sigma. And related to this we have two more notations. One is sigma plus and another is sigma star. So sigma plus is nothing but the union of all the powers of sigma, starting from sigma 1 union sigma 2 union and it goes on. So how we can write here? It is 0 comma 1. As we know, in union we simply combine the elements of the different sets in one single set. So 0 1, 0 0, 0 1, 1 0, 1 1, and then all the three symbol strings will be coming. So this is, as we can see, an infinite set. And here the difference between sigma to the power plus and sigma star is that here we'll be having sigma plus, and also we'll be taking the union epsilon. So this will also be containing the empty string epsilon. So the last concept that we'll be seeing here today is nothing but language. So a language is nothing but, suppose we are given uh, suppose we have been given with the alphabet set sigma. So a language is nothing but, for any alphabet sigma, a language is any subset of sigma star. So suppose here we have sigma is equal to 0 comma 1. So I'll be defining here different languages. So as we know that sigma star, what all it will be containing, as we saw just now, it will be an epsilon, 0 1, 0 length string, 1 length string, then strings of length 2, and it goes on. So any subset of sigma star will be considered a language defined over the sigma. So we'll suppose this, we have L is equal to 0 1 0 0, or suppose we have L is equal to 0 0 1 0 0 0 0 0 0 1 0 0 1 1 0 0 1. So as you might have noticed, what I have written this string, let's say this is L2. L2 I have written just a set of all the strings where the string is starting with 0. So this is the concept of language.